First question is about what is the charge? The extra degree of freedom which is responsible for any force is defined as charge of that force. Okay, जैसे for example mass is responsible for gravitational force, electric charge is responsible for electric field, as I have already discussed in the lecture. Okay, the second question type, the second question, why opposite charge, electric charge attract and similar charge repel? Answer will be yes. Why? What is the answer? Because all attractive forces must be a negative and all repulsive forces must be positive. So positive and multiply with the minus, result will be a minus, so that will be attractive. Minus multiply by minus or plus multiply by plus will be a plus, so that will be a repulsive. Okay, what is the work done? Okay, so work depend upon the path or displacement. Question is, work depend upon the path or displacement? Answer is generally work depend upon the path, not displacement. Work depend upon for only force which belong to conservative force. The work done by conservative force always depend upon the displacement, not a path. Generally work depend upon the path, but class of the force which belong to the conservative force will be work done depend upon the displacement. Okay? The conservative force is the class of the forces for which the work depend upon the displacement. That is the difference between the generally force and conservative force. Okay, what will be the work done for closed path? Closed path के लिए work क्या होगा? Generally work done for closed path will be not equal to 0, because generally force is not a conservative force. Work done for closed path is 0. Work done by conservative force for closed path will be a 0. Question, if we come back to home again, what will be the total work? Is it 0? Answer will no, because work done by human or a motorbike or a car is not belong to the conservative force. That's why work will not 0. Okay, what will be the work for closed path if the force belong to the electric field or magnetic field or belong to gravitational force or elastic restoring force? What will be the work for such kind of forces for closed path? Answer will be, it will be a 0. Why it will be 0? Because electric force, magnetic force, elastic restoring force, gravitational force, all these forces are a conservative force. Okay, and work done for conservative force is 0 for closed path. Is any all type of energy may convert into the potential energy? May we convert all type of energy convert into the potential energy? Answer is no. Only the conservative energy due to conservative force converted into the potential energy. Because what is the definition of what is the definition of potential energy? Work done against the conservative force, is defined as a potential energy. Okay, so the energy stored in a body when work done against the conservative force is defined as a potential energy. So the potential energy is true only for the work done by the conservative force. So only the conservative energy may write only in the form of potential energy. And the conservation of law, the kinetic energy convert into the potential energy, and potential energy will be converted into the kinetic energy, is only true for the conservative energies, not generally for all type of forces. Okay. Okay. We have defined the potential energy. What is the difference between the potential energy and potential? Potential energy per unit charge is defined as a potential. Okay. For gravitational force, potential energy per unit mass, and for electric potential energy, electric potential per unit charge, because for gravitational force charge is mass, and for electric force charge is electric charge, Q plus Q or minus Q. Okay, I have already it is written in the your course. What will be the work done by a man standing with holding 50 kg or any mass at the height of h height? The answer will be that will be equal to the potential energy stored in that mass, and that will be equal to mgh. Okay, mgh. So that will be work done by the man, which is done against the gravitational force. Okay, that is stored in the mass. What is the difference between the potential energy, difference in potential energy and potential energy? And potential energy.
Difference in potential energy and potential.
Difference in potential energy. What is the difference? Change in potential, yeah, difference in potential and potential energy. Difference in potential energy is always between 2 points, A and B. Okay, the difference of potential between 2 points, A and B. And what is the potential energy? Potential energy is actually known as absolute potential energy. Okay, and reference point will be defined at infinity. Okay, the reference point will be defined from infinity. Okay, for absolute potential energy. Okay, why reference point must be considered at infinity to define the potential energy? Yes, why? Because at infinity potential difference will be potential energy will be a zero. Okay, so that's why to find the absolute potential energy, potential energy, we have to consider the reference point at infinity. Okay, got it? Okay. Okay. 1 minute, please. What are the expression for potential energy and potential? What is the absolute? Sorry, what is the absolute potential? Or potential? Sorry, what is the potential? Reference for this answer is also the reference point must be at infinity. Okay, and the other point will be at specific point. Okay. Potential energy of electric field is a conservative or non-conservative? It is a conservative. What are the expression of for continuous charge distribution? What is the potential expression for electric potential for continuous charge distribution, for linear charge distribution? That is written on your notes. Okay. Okay. What is the equal potential surface? The next question is, what is the equal potential surface? The equal potential surface are those surfaces on which all point have the same potential. Definition. Firstly, definition, which all point on the equal potential belong to the same potential. There will the potential difference will be a zero because they have a same potential at every point. If we move on an equal potential surface, there will be no change in the potential. Okay, there will be no change in a potential. If we move on the equal potential surface, there will be no change on a potential. Okay, so every point on equal potential have the same potential. Got it? The question is, what is the condition that is comes in an exam? What is the condition for the equal potential surfaces? For such, yes, for such surfaces, the surfaces will be make angle 90 or orthogonal to the electric field. Okay. One minute. What will be the electric potential surface for a rectangular sheet? Since the electric field will be symmetric along the rectangular sheet, so that's why the rectangular sheet will be a equal potential surface for charge distribution, charge distributed on a rectangular sheet. Okay, I have already explained. Every point on a rectangular sheet, because this will be equal potential surface, so every point will be have the same potential for the charge distribution, same for the surface belong to the rectangular sheet. Okay. When the potential will be changed, when this equal potential surface move from one point to other point. But when point move on this equal potential surface, there will be no change in potential. But when the surface move from one point to other point, then will be change in equal potential surface. But if point move on the equal potential surface, then there will be no change in potential. But if surface move from one point to other point, then there will be change in potential. Okay. What will be the equal potential surface for a single charge distribution? If single charge for single charge, spherical surface will be equal potential surface for a single charge, electric field due to single charge. Okay, got it? Spherical surface will be equal potential surface for single charge, electric field due to the single charge, because the electric field will be spherical symmetric for a single charge. Okay, got it? The same answer is true for the charge distribution on the spherical shell. For if the charge is distributed on a spherical shell, the sphere will be equal potential surface for charge distributed on a spherical shell. Okay. So every point on a sphere of radius of constant radius r have same potential for a single charge or spherical charge distribution. Okay, got it? Okay. Next question. What will be the electric flux inside and outside the spherical charge distribution on shell? What will be the electric field, electric flux inside and outside the spherical charge distribution cell? Okay, so inside the electric flux will be 0, outside that will be a not 0. Why that will be not 0? Because electric flux will be non-zero for charge enclosed, because inside the point, charge enclosed will be a 0, So that's why electric flux inside the spherical shell will be a 0. Okay,
enclosed by the
outside will be enclosed, but inside the point will not enclose that charge. That's okay. अच्छा, एक important question रह गया था, वो कर लो. What will be the potential on different point? What will be the potential on different point on rectangular sheet for charge due to single charge? Yes. What will be the potential for different points on rectangular sheet for single charge? Yeah, due to single charge. Because due to single charge, sphere is equal potential surface. So different point at rectangular sheet will have a different potential. That will be not equal potential surface. Okay? So as we know that due to single charge, the spherical at every point on this sphere will have the same potential, but at sheet they will have a different equal potential, because they are not orthogonal to the point. So for rectangular sheet they will be a different. Okay, capacitance for parallel plate sheet. Yes, for parallel plate sheet, to find the capacitance of parallel plate sheet, we have to consider the charge distribution on both surfaces, both sheets. Okay, charge distribution on the both sheets. Why? Because both will be produce electric flux, and capacitance will be produced, and the capacitance will be due to the electric field due to both the plates. Okay, so that's why the charge distribution on both surfaces will be considered. Okay, what will be the equal potential surface for parallel plate capacitor? That will be a rectangular sheet between that parallel plate capacitor. And when we move, what will be the change in potential if point move on that sheet? That will be a 0 change. Okay, when there will be change in electric flux when this sheet move from sheet 1 to sheet 2. Okay, all figures are important. Short question में figure के हिसाब से भी दिया जा सकता है. ठीक है. अच्छा, why we will when this sheet move from first plate to second plate, then there will be change in potential. But if the point move on this Gaussian surface, there will be no change in a potential. So that's why we will consider the integration from point from first capacitor to second capacitor. Okay, which charge will be considered for to find the capacitance of spherical capacitor? For spherical capacitor, okay, we will consider only the charge distributed on a inner shell. We will consider the electric flux due to charge distributed on an inner shell. Why? Because answer क्या होगा? Why? Because only the charge inside distributed on inside sphere will be enclosed by the spherical Gaussian surface. Okay, please be silent. Okay, and same is true for the cylindrical charge capacitor. What is the firstly question was what is the Gaussian surface for what the Gaussian surface we must be considered for electric field due to the charge distribution on a wire. The answer will be we must consider cylindrical surface because it will be a cylindrical symmetric. And electric flux, and what type of electric flux we must consider for this charge distribution on a line? Electric flux will be only along the round surface, and that will be 0 for top and bottom. Okay.
Yes.
Okay. So what will be the what will be for a rectangular? That will be cuboid, and for cuboid we will consider Gaussian surface must be considered cuboid, and electric flux will be considered along the top and bottom, and 0 along the corners are sides. Okay. Okay. For a charge distributed on a spherical shell, the Gaussian surface will be a sphere, and electric flux will be passing through from whole sphere, entire sphere. Okay, that will be the same for all sphere. Okay, तमाम side पे same होगा ना. Okay, okay, and for the electric flux inside the Gaussian surface, inside the spherical shell will be 0, and outside will be non-zero. Okay. Okay. For what will be the electric? What will be the Gaussian surface for charge distribution on a cylindrical cylinder? That will be cylindrical symmetric. Gaussian that will be cylindrical symmetric. So Gaussian surface must be considered as cylindrical cylinder. Okay, Gaussian surface must be a cylinder. The electric flux at top and bottom will be considered 0, and so electric flux will be considered along only the round surface of the cylinder for this case. Okay.
Yes.
Okay. To find the capacitance, why we not consider the variation of point on rectangular Gaussian sheet? Answer is electric flux. Because the rectangular surface will be treated as equal potential surface for this parallel plate capacitor, and the motion on and variation of the point on rectangular sheet will be 0. The variation of point will not affect the potential on a rectangular sheet.
Gaussian surface is equal potential surface.
हाँ,
ये mean उसकी
you may say that. Okay, because it is a Gaussian surface. Yes, ठीक. And so why we have to consider from motion from variation of point from rectangular sheet for parallel plate capacitor? Why we have to consider from motion variation from plate 1 to plate 2? Because the change variation in the potential will be when motion from plate 1 to plate 2. Okay. Similarly, the case for spherical shell, the sphere will be a equal potential surface, no change in equal potentials, no change will be potential on different point on that sphere inside the spherical capacitor plate. So variation will be considered from inner surface to outer surface. Okay. So the limit will be R1 to R2 for.
Since there's no change on the potential or at equidistant surfaces, that why we consider motion from inner surface to outer surface.
Yes, that's the right answer. So, okay. Now the question: what is the area of the cylinder? That is because the cylinder is the combination of the circles, and area is the length of the multiplication of the two lengths. One is so circumference of the circle is 2 pi r and length of the cylinder is L. So area of the cylinder will be 2 pi r h. Okay. For parallel plate capacitor, we will consider the charge distribution on both charges, because electric flux will be produced due to the charge distribution on both of the sheet. Okay. Both of the sheets for parallel plate capacitor, but for spherical capacitor, we will consider the charge distributed on the inner sphere, spherical cell, not outer. Because what is the reason? Because Gaussian surface will the charge enclosed by Gaussian surface will be only due to S1, not and will be enclosed only the S1, not outer surface. It will be enclosed only the inner surface. Okay, and electric flux will be zero for outer cylinder. The same is case true for the cylindrical capacitor. Only the internal cylindrical capacitor, the electric flux, only the charge will be considered of inner cylinder, because electric Gaussian surface which moving from R1 to R2 will be enclosed only the inner shell charge, not outer shell. ठीक है, ये टोटल जो है आपके डिफरेंट क्वेश्चंस हैं इससे रिलेटेड.